Today's lesson is on more two-step equations. By more, I mean you'll be doing more with these, or they're different two-step equations than the ones you had been doing. As we go through the lesson, you'll see why they're different, or why I call this lesson more two-step equations. So I'll do a little review with you, and then I'll show you some examples. So with these, you're still going to make your goal to isolate the variable. Still, what you do to one side, you will do to the other. And you're still going to ask what's with my variable on the same side of the equation, because of course you're going to need to undo that using an inverse operation in order to isolate the variable. So with these, you're going to see a number outside a quantity, and your instinct might be to distribute. What you actually could do, you could distribute the 2 and then solve it the way you've been solving it. It would still work. But there's actually a quicker and easier way to go about doing this. So rather than distribute the 2, which you're going to multiply, if you distributed, you could actually just divide both sides by that 2 right off the bat. So that's how we're going to go about solving all of these. Instead of distributing the 2, let's just undo it. So our first step would be to undo that times 2 that's outside the parentheses. So we're going to divide both sides by 2. And so again, why did we do that? Well, on the left side, the whole purpose was to undo the times 2 that was outside the parentheses. So what's left? Well, all that's left is what was inside the parentheses. So we're left with an x minus 6. And on the right side, 10 divided by 2 leaves us with 5. So now this just looks like a one-step equation with a x minus 6 on the left side. So we have x minus 6. So what's my variable? It's x. What's with it? Minus 6. How do I undo minus 6? Well, I add 6. So what I do to one side of the equation, I must do to the other. When I add 6 to both sides, well, why did I add 6 to the left? To undo subtract 6. So that is now gone. And I'm left with x on the left, and on the right, 5 plus 6 is 11. So x equals 11. So if I substitute 11 back into my equation, I should get a true statement. So let's go ahead and do that. Let's do the check step here. So if I do 2 times the quantity, 11 minus 6, do I get 10? Well, what is 11 minus 6? 11 minus 6 is 5, and 5 times 2 is 10. Everything works out. Let's try another one. So I have 3 times the quantity, x plus 4 equals 18. So again, it wouldn't hurt anything if you distributed, but it's an added step you don't need. So you could distribute and get 3x plus 12, subtract 12 and divide by 3. It's an added step you don't need to do. You could just right off the bat get rid of the times 3. So that's what we're going to do. So we're going to divide both sides by 3. And just undo that times 3 that's outside the quantity. So what I do to one side, I have to do the other. So why did I do that? Just to undo that times 3 that's living out there. And so that's gone. And so on the left, all I have left is the x plus 4 inside the quantity. And on the right, 18 divided by 3 is 6. So now on the left, I have my variable x, and I still have a plus 4 living there with it. So how do I get rid of plus 4? That's right, I divide by 4. So I'm going to divide, no, I don't divide by 4. What am I talking about? How do I get rid of adding 4? That's right, I subtract 4. What I do to one side, though, I have to do to the other. Just making sure you're awake there on the other side of video land. So I subtract 4 from both sides of the equation. Why did I do that? To undo the plus 4. So what's left is an x. And on the right, 6 minus 4 is 2. So the solution to this equation, the x value that makes this equation true is 2. So if I substituted 2 back in, everything here should work out. So 3 times the quantity 2 plus 4 should give me 18. Well, what is 2 plus 4? 2 plus 4 is 6, and 6 plus 3 is 18. Everything works out. I must have done things correctly. The solution to this equation is x must be 2. Let's try another one. 5 times the quantity, y minus 10. Again, it would not hurt anything if you distributed the 5 and then solved from there. You would still get the correct answer. It's just an added step you do not have to do. So the shorter, quicker, easier way to do it is just to undo the times 5 that's living outside the quantity first. So we're going to divide both sides by 5. And we will get y minus 10 on the left because I was just undoing the times 5. And we will get 5 on the right. And now I still have a minus 10 with my y. And how do I undo minus 10? I undo that with a plus 10. So I'm going to add 10 to both sides of my equation. What I do to one side, I have to do the other. And on the left, I end up with a y. And on the right, 5 plus 10 gives me 15. So the y value that makes this equation true is y must be 15. So again, I'll go ahead and substitute that back in and make sure that it works. So 5 times the quantity 15 minus 10 should give me 25. So 5 minus 10 is 5. And 5 times 5, yep, it gives me 25. Everything works. Works out. Good to go. So y is 15. Makes this. Here's one with a fraction. So 1/2 times the quantity 3 plus x equals 7. So how do I undo that times a half? I divide both sides by a half. But you might remember that dividing by a half is the same as multiplying by 2. So over here I did it just to undo so I won't worry about turning it into multiplying by 2. But over here I'm going to rewrite dividing by a half as its reciprocal times 2 over 1. So I'm going to now think of 7 divided by a half as 7 times 2 over 1. Well, 7 over 1 times 2 over 1, 7 times 2 is 14 over 1, which is really just 14. So now I have 3 plus x equals 14. So I can really, when it's over 1, I can just really call that just 14. So instead of scribbling it out, I'll just erase it. Let me cover that back up with some pink so we don't have an open spot here. All right, so 3 plus x equals 14, and now I have x plus, oops, I better fix that so we can see it. Sorry about this. Okay, so I have my variable is x. What's with it? Plus 3. How am I going to undo that plus 3? I'm going to subtract 3. Again, what I do to one side, I must do to the other. So I'm going to subtract 3 from both sides. And now I can see that the solution is x equals 11. Because 14 minus 3 is 11. Substitute it back in. Let's make sure this all works out. So I need to substitute 11 back into my original equation. So I have 1/2 times 3 plus 11 needs to equal 7. Well, 3 plus 11 is 14, and 1/2 times 14 is 7. It all works out. One last example here. 2/3 times the quantity x minus 4. So I'm going to start by undoing 2/3. I'm going to divide both sides by 2/3. You might remember that dividing by 2/3 is the same as multiplying by 3 over 2. So I'm just going to go straight for multiplying by 3 over 2 this time. So I undo over here, and I end up with x minus 4, and 8 times 3 over 2 is like saying 8 over 1 times 3 over 2. So I multiply my numerators. 8 times 3 is 24, and 1 times 2 multiplied by my denominators is 2. Well, 24 over 2 is really just 12. So I'm going to rewrite that as 12. So x minus 4 equals 12. So what's my variable x? What's with it? Minus 4. How do I undo minus 4? I add 4. What I do to one side, I do to the other. So I end up with x equals 16. Again, you're going to want to do your check step and make sure everything works out. So I have 2/3 times x, oh, not x, but times 16, because x is 16 in this case, minus 4. Well, I know 16 minus 4 is 12, and I just need to figure out what 2/3 times 12 is. So I'm running out of space here, so I'm going to do it off to the side. So 2/3 times 12 over 1. Well, 2 times 12 is 24. Oh, and 3 times 1 is 3. 24 over 3, 24 divided by 3 is 8. So it all did work out because I was looking to get 8. So there you have it. So everything is similar to what you've been doing. Again, you could distribute and then you know, solve the two-step ways that you've been doing. It wouldn't hurt anything. It's just an added step you don't need to do. So tomorrow in class, if you'd like, I will show you that you get the same answer either way, but in order to not make the video go super long, I didn't want to spend time proving to you that if you distributed, you still get the same answer. And this is the shorter, quicker, easier way to do it. So I hope you have a good night. I'll see you in class tomorrow. Hopefully you filled out your note sheet. Glue it in your notebook tonight so we don't have to spend class time tomorrow doing it, okay? Have a good night. Adios.